going to be going over the main concepts of one of our first units, polynomial equations. So we're given x-intercepts of -6, -1, 4, and then a y-intercept of -6. So I'm going to plot the x-intercepts first. There's our -6, there's our -1, and there's our 4. Our y-intercepts will be -6 down here. So we would have x plus 6, as once this is set to equal 0, and you bring the 6 over, it'll equal -6. X plus 1, which represents the -1, and x plus 4, or -4, sorry. We will have an a value though, as we need to determine what that is when in regards to our y-intercept. We know our y-intercept is 0 and -6, and we can plug that in and isolate for a to get that. So 0 will be our x, -6 will be our y. This becomes -6, and we substitute 0 in for x. Zero plus 6 is 6. 0 plus 1 is 1. 0 minus 4 is -4. When we multiply these together, 6 times 1 is 6, times -4 is -24. -6 over -24, we can simplify down to make that 1 over 4. So our equation is f at x equals 1 over 4, x plus 6, x plus 1, and x minus 4. Now for this function, what intervals of that would be negative? So we would begin with -infinity all the way up until -6, where it passes the x-axis and is no longer negative. And then u to connect back to -1, where it dips below the x-axis again, becomes negative again, all the way to +4, where it passes the x-axis again. Okay. For this one, we have two x-intercepts and a y-intercept. So again, I'm going to plot that, -4, 1, and our y-intercept down here, -16. To get -4, it would be x plus 4. So once this factors out, it would be -4. And this is going to be squared, which lets us know that this just touches the point and then turns around again. And our next intercept is x minus 1. And if we were to make sure this works with our y-intercept, we can set x to 0, which would make this 0 plus 4 squared, and 0 minus 1. 0 plus 4 is just 4 squared, times -1, and 4 squared is 16, times -1 is -16. To a word problem. Here we have a rocket is launched in the air, and its height is modeled by the graph h at t equals -t to the 4 plus 10t to the 3 minus 35t squared plus 50t plus 100. T is time in seconds. The rocket is in the air from t equals 0 to t equals 8, and we want to find for how long the rocket is above 100 meters. So we can rewrite this in a way that says the function is greater than 100 meters. Just write this out. Begin by bringing this 100 over to the other side. That's going to make this -100 is equal to -t to the 4 plus 10 to the 3 minus 35t squared plus 50t. When we factor out negative t, this positive 10 becomes a negative. This becomes a positive 35 rather than negative 35, and the 50 becomes negative. And when we plug in 5, we get 0. So now we can use synthetic division and use all the coefficients being 1, negative 10, 35, and negative 50. 1 plus 0 is 1, times 5 is 5, negative 10 times 5 is negative 5, negative 5 times 5 is negative 25, 35 minus 25 is 10, 10 times 5 is positive 50, negative 50 plus 50 is 0, remainder of 0. So now we have x squared minus 5x plus 10. And our previous one of t minus 5, sorry. Trying to factor this may be a little difficult looking at it because nothing multiplies to 10 and adds to negative 5. So before we can even try the quadratic equation, we can find the discriminant. And if it's below 0, then that means there are no x's. That's going to give us negative 15, which is below 0, meaning there's no x-intercepts or no factors for this one right here. So that's not going to count. So all we're going to have is negative t from up here and t minus 5, meaning t is equal to 0 and t is equal to 5. So our interval for when the rocket is above 100 meters would be from almost instantly after it launches all the way to 5. Now we're going to solve some inequalities. And we're going to begin with negative 4x times 4x plus 9 times x minus 8 squared is greater than 0. We want to begin by getting the x-intercepts for all these. For this one, x would be 0. X would be, move the 9 over, it becomes negative 9 divided by 4. It's negative 9 over 4, which would be around negative 2.25. And then x equals 8. Now we can plot this on a number line. Put 0 in the middle, our positive 8 over here, and our negative 9 over 4 here. And we want to find things that are greater than or in between these. So for 0 to 8, we can do 4. From 0 to negative 9.4, we can do negative 1. For greater than 8, we can do 10. And for simplicity, we'll do negative 10 over here as well. Now we're going to plug each of these into the x's here. So when we put negative 10 in here, negative 4 times negative 10, that's going to be positive. 4 times negative 10 is negative 40, plus 9 is a negative, and then negative 10 minus 8. But because of this square here, no matter what we put in here, it's going to be positive unless we put in 8, because in that case it'll be 0. So since we're putting a negative 10, it doesn't matter, this is going to be positive. Positive times a negative is a negative, times positive is a negative. This is negative. So for negative 1, put that in here. Negative 4 times negative 1 is positive. 4 times negative 1 is negative 4, plus 9 is positive. Negative 1 minus 8, it's not 8, so it's going to be positive anyways. Positive times positive times positive, positive. Negative 4 times 4 is negative. 4 times 4 is 16, plus 9 is positive. This is positive. Negative times positive is negative, times positive is still negative. And finally for 10, negative 4 times 10 is negative. 4 times 10 plus 9, positive. And it's going to be positive here too. Negative times positive, negative, times another positive, still negative. But we wanted when it was greater than 0. Now for that, the only interval where it's greater than 0 is from negative 9 over 4 to 0. this one, we're gonna have to factor out first. Now something that we can factor everything out of here is 2x. So we're gonna do that. This is gonna become 2x squared. That's gonna become negative 11x, and that's gonna become negative 6 with no x, is less than 0. Now with this, we can factor this out by getting different factors of a and c, that being, and cross multiplying. We can do 2 times x plus 1 and and a single x minus 6. Now we know our x-intercepts would be, move that 1 over, becomes negative 1/2, and this becomes 6. So again, plus the number line, we have our 0, we have our negative 1/2, we have our 6. To find things in between these, we do negative 0.25, and 10 over here, and again, for simplicity, negative 10 over here. So, plugging in negative 10, 2 times negative 10 is negative. 2 times negative 10 plus 1 is still negative. Negative 10 minus 6 is negative. Negative times negative is a positive, times negative is a negative. Negative 0.25 put in here is going to give us a negative. Negative 0.25 times 2 plus 1 is going to be positive. And negative 0.25 minus 6 is negative. Negative times a positive is negative, times a negative is positive. 3, 2 times 3 is positive. 2 times 3 is 6, plus 1 is still positive, and then 3 minus 6 is negative. Positive times positive, positive times a negative, negative. 10, 2 times 10 is positive. 2 times 10 plus 1, positive, x minus 6, positive. Positive times positive, all still positive. Now for this case, we wanted where it was less than 0. Now for this, it's going to be from negative infinity all the way to negative 1/2, connected with a u, and then 0 to 6. Next, we're going to do finding the average rate of change and the instantaneous rate of change for the function between x and 4 and the IROT for x equals 4. So to do this, we're going to start by plugging in each of these, 4 and 6. So when we plug in 4 to the power of 4 minus 4 times 4 to the power of 3 plus 6 times 4 to the power of 2 minus 4 times 4 plus 1, 81. We're going to do the same for 6. That is going to give us 625. So, to find the average rate of change, it is f at x2 minus f at x1 over x2 minus x1. So when we plug that in, we get 625 minus 81 over 6 minus 4. That's going to be, 540 divided by 6 minus 4, which is 2, which is going to be 272. Now we need to find the instantaneous rate of change for x equals 4. So f at 4.001 equals 4.001 to the power of 4 minus 4 times 4.001 to the power of 3 plus 6 times 4.001 to the power of 2 minus 4 times 4.001 plus 1. And that's going to give us 81.108. So this becomes our new f at x2. So when we use the same equation, we get 81.108 minus 81 over 4.001 minus 4. This is going to give us 0.108 over 0.001, 108 at x equals 4. Now let's just try determining whether a function is odd, even, or neither algebraically. We're going to start off with this function here. G of x equals 3x times x squared minus 9. So to do so, we're going to substitute x for negative x. In any x that we can see in this equation, negative x squared minus 9. Now, this just becomes 3 times negative x is just negative 3x. And negative x squared, that's going to be negative x times negative x, it's going to become a positive. So it's going to be x squared minus 9. Now, this is our g of negative x. And this is not the same as our g of x. So g of negative x does not equal g of x. So we know it's not even. But we can still determine if it's odd by now finding negative g of x. It's going to be negative 3x x squared minus 9. So when we distribute that negative 1 to it, that's going to become negative 3x and x squared minus 9. Looking at our negative g of x, this is the same as our g at negative x. So negative g of x is equal g of negative x. So it's odd. This one, we have h at x equals 2 times x to the 3 minus 4x. Again, same thing. Substitute x for negative x. It's going to be 2 times negative x to the 3 minus 4 times negative x. So this is going to become negative x to the 3 is the same as saying negative x times negative x, which is positive x, times another negative x, so it's going to be still negative. Negative 4 times negative x is going to be positive 4x. This is our h at negative x, not the same as h at x. So h at negative x does not equal h at x. Let's try for negative h at x, which would be negative 2 times x to the 3 minus 4x. When we distribute that in, it's going to be negative 2 x to the 3 minus 4x. And that does not equal our h at negative x. So our negative h at x does not equal h at negative x. So it's neither even or odd. This one, same thing. P of negative x equals negative x minus 2 to the power 3 plus x plus 2 to the power of 3. Because of this power of 3, this is still going to be negative. Same thing here. This is still going to be negative. We can factor out negative 1 from here. which will make this positive x plus 2 to the power of 3. We can do the same here even. We can factor out negative 1, which makes this positive x minus 2 to the power of 3. Now, negative 1 times negative 1 is just a positive 1, so those really just cancel out. That leaves us with x plus 2 plus x minus 2 to the power of 3. This can simply just be rewritten as x minus 2 to the power of 3 plus x plus 2 to the power of 3. Doesn't matter because it's just addition. And that's the same as this. So our p at negative x is equal to our p of x, meaning it's even. Now let's do some finite differences where we have a function and we ask which finite differences would be the same and what would their values be. We know that the nth finite difference is going to be the same, which is our leading coefficients. So we know the fourth difference is going to be the same. But what would that value be? Well, to find the value of that, it's going to be our a times our nth factorial. So our a is 1/2. So it's going to be 1/2 times our nth difference, which is the same, which is 4. So 4 factorial. So that's 1/2 times 4 factorial, which is 24. 1/2 times 24 equals 12. But how about this one? So which finite differences would be the same? Our 8 is going to be the same because that's the exponent on our leading coefficient. So the 8th difference will be the same. A times n factorial is going to give us that value. Our a in this case is negative 2 times 8 factorial, which is going to be negative 2 times 8 factorial, 40,320, because that's 1 times 2 times 3 all the way up until 8. Now we're going to multiply that by negative 2, so we're going to get a negative 80,640.